welcome to Algebra. I'm Barb. In this video, I'm going to talk about simplifying radicals and rationalizing denominators, and also a little bit of operations with radicals. So the first thing I'm going to show you is how to simplify a radical. Basically, the idea is that we want to take the biggest perfect square that's like buried inside the number outside of the radical. I like to use the factor tree breakdown method. And I am going to break down 320 in this problem into all of its prime factors. This could take a little while, but it's okay. So 320 is 2 times 160. And I always start with 2. And then if it's not divisible by 2, I go up to 3. But I like to keep the numbers on the left side of my tree small. So 160 is 2 and 80. 80 is 2 and 40. 40 is 2 and 20. Wow, that's a lot of 2s. 2 and 10, and 2 and 5. And once I have it broken down, I want to circle all of the pairs of the same number. So I have a pair of 2s, another pair of 2s, and a third pair of 2s. And then I'm going to take one representative of each pair outside of the radical. I'm going to take out a 2 from this pair, multiply it by a 2 from this pair, and multiply it again by a 2 from this pair. And then this poor lonely 5 doesn't have a buddy, so he has to stay inside the radical. So far what I have is 2, 4, 8 on the outside, and this 5 stays in. Now I'm going to deal with the variables. So x to the 8th, 5, 6, 7, 8, is basically 4 pairs of x's. So I'm going to take out x to the 4th, and there are none left over. I had exactly 4 pairs in 8. So the easiest thing to do is just divide your exponent by 2, and however many times it goes in evenly, you take that many of your variable out. So let's look at the y. 9 divided by 2. 2 goes into 9 4 times evenly. So I'm going to take out 4 y's, but there's 1 left over. And then for the z, 15 divides by 2 7 times evenly to get me to 14. And then there's 1 z left over. So this is my final breakdown. This is the most simplified that this radical can be. So that's how you do that type of problem. Next up, I'm going to look at adding and subtracting radicals. So it sort of works like a variable. You can only combine radical expressions if the radical part matches exactly. But here I have the square root of 54 and the square root of 6. Obviously, they do not match. However, 54 can be simplified. So let's break that down. 54 is 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. What pairs do I have here? All I have is one pair of 3's. So I'm going to take one representative from that pair and multiply it by the 3 that was already out front. So that gives me a 9 out front. And then I had a 2 and a 3 left over unused that didn't have a buddy. So I'm going to multiply those two together. So 2 times 3 is 6. And that stays under the radical. This one is already simplified. But look, now my radicals match and I can add them together. So 9 root 6 plus 5 root 6 will give me 14 root 6. And I'm done. Okay, third type of problem is rationalizing the denominator. I am not allowed to have a radical in my denominator. It is against the rules, and I have to get rid of it. So when I have an expression in the denominator that involves addition or subtraction, I want to do what's called multiplying by the conjugate. The conjugate of this expression, 4 minus root 3, is the same thing but with the opposite sign in the middle. So I'm going to multiply the top and the bottom of this fraction by 4 plus root 3. And you'll see what happens. So I need to distribute this 5 to each piece inside the radical. So 5 times 4 is 20 plus 5 root 3. That's my numerator. And then in the denominator, I have to FOIL 16, and then I'll have minus 4 root 3 and plus 4 root 3. So those middle terms will drop out. And that happens every single time, which is beautiful. So I'm always going to have this one squared, the middle ones cancel, and then I'll have minus root 3 times positive root 3, which is negative root 9, or just negative 3. So this is always going to FOIL and be the first one squared minus the second one squared, which in this case is 16 minus 3. Now, put it all together. I have 20 plus 5 root 3 in the numerator and 13 in the denominator, and nothing can be simplified, so I'm done. I just want to show you one other thing. Suppose I just had a simple radical in the denominator, where it wasn't an expression that had a plus or minus. In this case, it's a little simpler. All I need to do is multiply top and bottom by the square root of 5, whatever's in the denominator. And my numerator is now root 5, and my denominator is root 5 times root 5, or root 25, which is just 5. And this is my final answer. So anytime you square a square root, it undoes it, and you're just left with what was under the radical. I hope this was helpful. We're turning negatives into positives. Have a great day.